All right, we'll go ahead and get started here. Welcome back to the DAC Pavilion. Our first panel this afternoon will feature John Lee, GM and VP for Electronics, Semiconductors, and Optics Business Unit at Ansys. And he's going to lead our distinguished panelists in an exploration of bespoke silicon, tailor-made for maximum performance, where they'll share their experiences about this emerging market. John.
Yeah, thank you, Tom. Yep. Hey, good afternoon, everyone. It's a real pleasure for us to be here in person and to see the attendees. Just as a very short opening, the analogy to a bespoke suit is one that we think applies here. A bespoke suit, of course, is one that's custom-made, tailor-fit for your particular application, in that case, a body. And we've seen such bespoke silicon being a trend across the industry. The one that I'll talk about, that's fairly obvious, is from Apple, as they've developed their M1 and M2 processors, and being able to really customize to their application, including software, it seems to be a trend. With that in mind, we have here a very esteemed panel to help share insights, challenges, and predictions for this new trend. And we'll go through a short round of introductions. Cam is the Vice President of Product Management for Cadence's Digital and Sign-Off Group. He's been in the EDA industry for 25 years. We worked together for at least 5.
At least so.
Yeah. In various technical and business development roles supporting advanced digital design. We also have here Prashant Varshney, is a 20-year semiconductor and EDA veteran, is now head of product for the silicon industry vertical at Microsoft Azure, with a mission to make Azure the platform of choice for EDA in the cloud. Yep, welcome, Prashant. And Mathew, who may look like he's 20, but I know is a little bit older than that, is a semiconductor professional working both for a major tool vendor as well as a major mobile device corporation. So welcome, Mathew. So to get the panel, to get started, I thought just since I did a very formal introduction, I could ask our panelists a surprise question. The question is, why did you get into the high-tech semiconductor business? And how would you describe what you do to a family member who's not in tech?
So first of all, how did I get in high-tech business? It was a friend of mine in high school who determined that the best paying job out of a bachelor's degree was electrical engineering. And so that set us on the course of that's the job for us. We didn't know anything about it.
It's about the money.
That's right. It was about the money. So, and yes, it's been, and also the fame, so. But what was the second part of the question? I forgot. John.
And how would you describe what you do today to your, like, in my case, my mom, who's not techie?
Right. Well, what I usually do when I talk with people is I say, you've got this type of phone. I know the guys that designed the chips that went into that phone, right? And they're like, oh, really? Like, yeah, they use our software to make those chips and make your phone work. And so that's basically it, so.
I like that, yeah. Prashant.
So how I got into, I think reasons are very similar to what Cam just said. And when I graduated back in '98, VLSI was something that was starting to become almost mainstream, coming out of exclusivity. And so it was quite intriguing just to see, hey, how in software you can do things that you were actually supposed to do physically, draw wires, etc. So found it quite interesting. So that's how I kind of got into it. It was extremely hard for me to explain to my family members what I do for a living, and so this is like 20 years ago. Even chips was not a understood concept. So I would break open a keyboard and then show them, here it is, what a chip looks like, and I wouldn't break up a phone. So obviously, but yeah, that's how I would say that. Hey, this is what I do. This is what we design. And it's intricate work, but yeah, they would just say, yeah, okay, that's fine.
All right, good. How about you, Mathew?
Yeah, actually, Cam stole both my answers. It's a very similar story for me as well.
Yeah.
So yeah, in university, we had a couple of folks who were already in the EDA industry who had raving feedback about the kind of work, the innovative work that is done. And I just followed, their great advice, and that's how I started off. Yeah, and explaining to family has always been a challenge. So as a child, I always enjoyed breaking things, taking it apart. I would never know how to put it back together. So I have these little boards, PCBs that were always there around. I would point to them and say, you see the little black thing on the board? Yeah, that's what I do.
I like it. Well, thank you. So let's start the technical side. I mentioned bespoke silicon, the example of the chips that Apple does. The question is, why is this happening? And what are some typical use cases? What are examples that you see across all industries? And perhaps for this, I'll ask Prashant first from this perspective of Azure.
Sure. Yeah, as a major cloud provider, I can give my take from that perspective. I started to look at obviously different end applications. So what I see is that so obviously you're looking for semiconductor development work, ranges all the way from obviously high margin, low volume type of business, all the way to high volume business. And what's now happening is that if you start to look at high volume business, like a data center, for example, everybody's starting to look at how can we optimize this? How can we optimize this now? To start the development work with some general purpose silicon, but over time you have to look at when things go mainstream, then how we now optimize on a performance on a per dollar basis. That becomes the most important matrix to optimize. And so how do you do that? So you had at the silicon level, you had certain optimizations. Software level, you have some optimizations. But now people are starting to now look at a system level. Okay, this entire system is, as a whole, as an entity, I need to be able to optimize. Now you drill down those custom requirements and start to now look at all the pieces that build up the system and how can we optimize them further. So that's the inspiration, at least from the data center perspective, start to look at custom silicon is going to hopefully be able to optimize that cost down, that we can then pass on to our end customers. So that I see as from the data center perspective as the motivation for doing Bespoke.
Yeah, it's been an interesting change, and it's driven by what we call the hyperscalers or cloud compute companies, because the economics has changed, right? What the function for them is that they need to provide a software service to someone, and they need highly scalable cloud compute to do it. Once you start breaking it down, the bespoke silicon starts making a lot of sense, especially at this volume. And so, like one of the things that we saw early on was, you may, for the way that things, the market worked before, is that semiconductors would make a chip, they would sell it into system companies would sell this into larger systems, especially if you may make a server that somebody makes a data center out of, And so, especially when you start with networking, you would make networking equipment that would handle a vast array of different scenarios, meet a lot of customer needs. When it gets down to one customer, there's lots of bells and whistles that they want to eliminate on this thing, get it down to the bare bones of what they can do. And so making that custom silicon for that makes a lot of sense. Annapurna was one of the first ones that we were looking at from our side. That was very interesting that they were making their own hardware, and we knew that they were making some sort of processor in this. And so at the annual event for AWS for reInvent, they talked about what it was. I thought that it was just going to be, they replaced the Intel CPU with an ARM processor or something like this. And so, but what they did is they replaced the hypervisor function that was software driven and was using a load of the payload, the things that they're charging money for the CPUs. You could offload that into hardware completely. And so this was, and that was very interesting, because that's exactly like what the guys that were doing cell phone base station work were doing before. They were taking software applications, pushing as much of that down into hardware, and so this is happening in the cloud as going forward, and it's just, it's steamrolled from there.
Do you see other industries outside of cloud that have the scale and the need for bespoke silicon? Yep.
Is this whose question was this?
I'm going to ask you, Cam.
Oh, okay. I didn't know. Sorry, I didn't want to dominate this.
Yeah.
Yeah, we do see this, and one of the things that's interesting, if we go back a few years ago, it was, mobile devices was driving the market, and then everybody had their mobile device, and it looked like everything was saturated. What's coming next? 5G really did change the game in this. AI has changed the game, right? So, and people making their own AI architectures, that's driving bespoke silicon, you know, because it's hardware to drive a specific software stack. Then also what we're seeing on the people doing hyperscaler, as I mentioned, then on the edge with smart IoT, and all these things are converging. The people that are succeeding wildly, they're driving on all four of these major vectors at once, but it's driving more and more specialized silicon to fill in the gaps as it goes along the way. I don't know if it lasts like this forever, but it's definitely growing right now.
Indeed, indeed. I have a question for Mathew. Why isn't everyone doing bespoke silicon, or will everyone be doing bespoke silicon?
I think the obvious and simple answer is it's not simple to do bespoke silicon. There are a lot of challenges that you have to work through, and in the end, it's a risk versus reward scenario that you'll have to evaluate. You'll have to understand the risks of doing a bespoke silicon, whether the plan will actually pan out, whether your silicon will come back as a first-time success, whether it'll hit the performance that you want it to. And you'll have to balance that against the rewards of what is the magnitude of improvement you're seeing from your bespoke silicon. Is it really giving you enough return for the money that you've invested in? So it makes sense for a lot of folks to do bespoke silicon, where you are seeing great benefits and just minimized marginal risks. And we also have to balance risk rewards with, let's say, the timelines that you have. So bespoke silicon is often made for a very niche market, and you have to get your product out in the timeline that you want it to. So you have to make sure that the engineering teams can deliver on that timeline, and you also have to have a very strong team that's doing it. So all of these factors have to align to be successful with bespoke silicon, and that's probably why not everyone can do it.
So I have a follow-up question on that, and maybe for the other panelists. Tesla famously has designed some custom silicon that they've talked about, and as you think about the automotive industry, whether you're in Detroit or in Germany, for example, how would they follow that lead, or can they follow that lead, or do they need to follow that lead?
Did you know? Yeah, that's a very interesting, and that was an example of, you've got really an edge device, a car, a data center for processing the data. Everything was bespoke in this particular arena, and so and also machine learning AI accelerators built into the cloud, and so I think that. I'm not sure everyone will follow, or that they have to follow that, but I think that there's going to create some interesting partnerships, between people that already, if you're BMW and you need to do a self-driving car, do you make your own data centers and spread them all over the world, or do you partner with somebody that are already experienced in spreading these all over the world? I think there'll be some interesting applications for that, especially, to reduce cost as this becomes, it's not just your highest end cars, that are requiring this. So, but there probably will be more people that will do, follow that lead in the beginning at least.
I think I'm not an expert in the automotive field, but I do see that was a need to begin with when most companies who are pursuing autonomous driving, for example, they are doing their own bespoke silicon because that's how they all get started. There was no well-formed application segment except for certain entertainment applications, etc., in automotive before, and so this was something brand new, and everybody had to make investment on their own side to try and solve this problem because it's ultra high performance, and they really wanted to push that and still keeping the cost down. So that's how they started. It is possible that there might be some standardization done in that over time, that most of the automotive makers may identify a few players who now know how to do this well, and they might want to standardize on architecture, or even the players who are developing this on a large volume basis. But as of right now, we are not there yet, and everybody's just doing their own.
So I have a question about, as you think about bespoke silicon and those use cases, I'm curious, what's your opinion on how do the ASIC companies fit into this? ASIC companies like GUC, like Alchip, like Broadcom, Avago, have been building silicon for clients for many years. So does the trend for bespoke silicon create opportunities or headwinds for these companies?
I can start with that. So I think there are definitely opportunities there because let's say even if a company decides to do bespoke silicon, they may not do it all the way from RTL to GDS to final post silicon. So there are still pieces of the puzzle that they want to get help from an external ASIC vendor. So they could maybe do the RTL part of it, own the actual behavior part of it, but get somebody else to just implement that piece for them. So it definitely creates opportunities for the existing ASIC design vendors there.
Yeah, I'm old enough to remember when ASIC was dead. If you guys are, the whole model was going bust, and a lot of ASIC customers struggled. This is maybe 15 years ago or so, and so now they're just roaring. They've got more pride. Their problem is they don't have enough people to get all of the projects done, and a lot of this is being fed into what I call this hyperscaler push, which and basically it's a change in economics. They've got to get this software solution out, and they need to drive the hardware in order to do this. So there's lots of projects. It's a staggering the number of advanced node projects that are going on within the ASICs right now. I don't see it letting up anytime soon. Where does the bespokeness kind of consolidate into things falling, going by the wayside? I think that the AI chips were kind of in the wild west of AI architecture because one is that it's tailored to whatever software application that you want to run on this. I think that those every generation, like if you look at the NVIDIA roadmap, it's changed so fast, and provided so much benefit just from one generation to the next as far as throughput and power efficiency. That I think there'll be some standard architectures there and then standard software that runs on this as the industry becomes more robust.
So that's a good lead into the next question, which is, as you think about the large players in semiconductor that have focused on standard compute architectures, merchant silicon, for example, the x86 architecture, or even the NVIDIA GPUs, the bespoke silicon could seem to be contrary to that trend. And I'm curious, Prashant, from your perspective, is there room for both, or is it going to swing one way or the other?
There's definitely room for both. I mean, we see the merchant silicon still continuing to grow because the demand is just so high that, and Mathew put it right, I mean, these are all niche applications when we are starting, especially on bespoke. Because of customization, you by definition have a limited market that you're focusing on, but it's still mass market that still has to be served. And that will be served by the merchant silicon. Like I was saying, I mean, every platform design starts with a merchant silicon, a standard CPU first. And then you start to identify how to optimize this further going forward, depending upon what your market size is and what's the longevity of the platform that is, and is it indeed getting into the mainstream versus the early adopters. So depending upon all of those factors and the complexities of being able to do bespoke silicon, there is always going to be a majority that sits into the merchant silicon.
Yeah, last year, if you take the top 20, non-foundry semiconductors from the McKinsey report, or who does that report? I forgot what it was. It's somebody. Sorry, whoever does that report.
McDonald's?
Yes, McDonald's report. Saw it on a napkin. But if you take the top 20 semiconductors, the non-foundry traditional semiconductors, their revenue grew in 2021 by 26% on aggregate. It was everybody's doing good right now. So it's rising all boats. So the bespoke silicon, even though it's very it's eye-catching. It's in order to fill in the gaps between some classic silicon. Also, we see. I think this is going to change behaviors. The market dynamics of this, and we see it happening now, where and I think this will play into 3D IC, where people are making chiplets that you'll want to use your chiplet, and it'll be more of a bespoke 3D IC implementation where you're not having to do, it's really expensive to do a high-end CPU, so to do some other components, you can do it at a lower cost, and that may be the value add that people will go for in the long run.
And I'll also tie this back to the first question you raised, John. Why doesn't everyone do bespoke? So there is definitely a market, and there is definitely a need for general purpose compute as well. Bespoke does not make sense for all applications. So you will definitely see general purpose compute continuing. And you may, as rightly mentioned, you may see in the 3D IC kind of structures where you have your bespoke silicon getting mixed with a general purpose compute as well. So I think there's definitely room for both in the ecosystem.
So on the topic of chiplets, as you think about IP, IP could be standard cells, and with Carver-Mead, right, we went from fully customized designs to something much more scalable. So are chiplets a new form of hard IP, and if so, where are we on that journey? Is it years out that it'll be standardized and reproducible, or are we able to do that today?
I can pick it up. So on chiplets, definitely it's very similar to the way that we get hard IPs and just integrated as part of the design. But one thing that really stood out, and I think this was part of one of these talks here at DAC itself, is let's say you have a chiplet family with let's say 5 chips. To create the incremental next version of the same chip family, you don't have to rebuild all 5. So you can create your bespoke silicon for that one bottleneck or that one piece that you want to improve and still reuse a lot of what you already have. So which is very similar to what we have done for IPs. Mm-hmm. So I think that is a big differentiator, and I see a big value add of the chiplet family.
Yeah, I'm not sure that you would go and pick a chiplet that has a form factor and then mix and match it, that all of the requirements to make that a standard will come into place. But people that are doing 3D IC and making chiplets for the products they're selling now, I think they're going to add your own bespoke silicon to their solution, and they'll be a quasi ASIC provider on the high end.
So if you think about chiplets, it's a form of the most advanced technologies, process technologies like FinFET or now on the horizon, RibbonFET, advanced packaging. So I'm curious, for bespoke silicon, seems like a lot of them are using these most advanced technologies. So Mathew, first, if you could share, what are some of the challenges that designers are running into as they use these advanced technologies?
Okay. My answer may be a little biased here because what I've seen and a lot of the colleagues I've worked with were mostly working on first-time bespoke silicon. Yeah. So a big challenge for such teams is to work through the unknowns and the uncertainties that these advanced technologies are bringing in. Because when you're looking at first-time silicon, you don't have any data to back up on. So you don't have answers to the question saying, I had done it this way in the past and this worked. Or I had done it this way in the past and this did not work, this needs an improvement. We don't have any of this data available when we are doing first-time bespoke silicon, and that's very common in the industry. A lot of companies now who are doing bespoke silicon are doing it for the first time. So working through these uncertainties and unknowns in these advanced technologies, I think that's the biggest hurdle.
Yeah, one of the biggest challenges we see is just having the engineers to do the job, because it requires not just place and route savvy, but people that are. It's a lot different doing a 5 nanometer than it was doing a 28 nanometer. So they've already got to have their feet wet if they're going to hit the ground running on that advanced technology. But that's been the biggest challenge, and also with the ASIC providers as well. Everybody's headcount limited at this point.
Hey, for bespoke silicon, there's another form that I'd like your thoughts on. Programmable silicon architectures, for example, FPGAs, they do provide customized functionality. And we've recently seen both Xilinx and Altera join forces with standard processor companies, right, Intel and AMD. So a question for you, Prashant, how will programmability play into the future for cloud usage and other applications?
Yeah, I think the FPGA, the programmable logic in general, I think is starting to also evolve, and it has evolved over the last couple of decades. The performance has improved significantly. Their ability to start mixing standard processes with the programmable logic has evolved significantly as well, and we have started seeing that now. In a lot of custom silicon that's being developed, there's actually a combination of the two, and so they have standard GPUs or a CPU embedded inside programmable logic, to the extent that in some cases programmable logic may be smaller than the standard logic. So a lot of that is giving the designers the ability to now quickly run through different design styles, different software architectures, different algorithms, right? So I think that's going to continue for a while. And the gap between that programmable logic and an optimized ASIC is continuing to reduce as well. So it remains to be seen what eventually happens, but what we see today is it's an application of this mixed mode quite a bit, a whole lot more than in pure programmable logic.
Right.
That's right, yeah, because the FPGAs of today are not like they were, 10 years ago, which is like a sea of gates. There's like high-level functionality there. So, and they're targeted for specific applications. Like our friend Pramal, he's got a DPU FPGA specifically for that. So it can be customized. Always the downside with FPGA is power. And so if you've limited it to some special control functions, then maybe you pay a little bit of a power penalty, but you can get the customized version. The other customized versions may reduce power. So.
Another application that I've seen for programmable logic is when you have secure silicon development, when you have confidential algorithms that have to be encoded inside the chip. You don't want to implement that as an ASIC. That logic, that program, can be implemented as a programmable logic, and then the actual algorithm comes in the software. So that's another end application I've seen.
So software clearly fits into this, right? It's the software stack itself, and so I'm curious, how do the hardware and software teams work together? Because it's you kind of. Is software the long end of the schedule, or is it something that you can do concurrently? Is it something that's smooth or something that requires a lot of effort? I'm curious about your perspectives. Mathew first.
Yep. I think a lot of bespoke silicon that is created is meant to just run software. It's meant to take the software that was running on, let's say, general purpose compute and to take that to the next level. So it is very important that the hardware and the software teams work together. And this goes all the way through, your design creation. The software teams have to be very upfront on what is the expectation from the hardware and set up the specs. The hardware team and software team have to work together to understand, okay, what are the must-haves, what are the compromises that can be made, and this goes through the flow. And even post-silicon, software plays a big role. So you may have expectations of, let's say, X power from silicon, but you may see 2X when you actually run your software. And then there is that dialogue that has to happen between software and hardware to figure out, okay, is this an issue at the software end, is this an issue at the hardware end, and how we can improve this for the future. So there is a very strong tie-up and correlation required between hardware and software to get this done. And it's not easy. Often software and hardware folks, they speak different languages. So it's important that they all come to the same plane and work together to get bespoke silicon to the actual success level it needs to be at. Yep.
Good.
Yeah, just like as I'd mentioned before, that hypervisor example that AWS put together before, that was taking what was running in software and pushing it down into hardware so that it did it more power efficiently, offloaded your workload processor for this, and we're seeing a lot of the bespoke silicon is doing that time and time again. I mean, whenever you have a special AI architecture, it's so that it can run in hardware what you would have done in software otherwise in order to get the the compute per watt down.
I have a question, and maybe Cam, you could start off first. If you look at bespoke silicon, a lot of times, especially at the hyperscalers, it seems like these are brand new teams that are being stood up. And so the question for, are these teams more agile than traditional semiconductor companies? Are they more able to adopt the most advanced methods, or are they being more conservative because it's the first time doing silicon?
Well, they're usually not first time doing silicon. A lot of times these guys know each other, whenever they're going over to do this, and so they have to be pretty well advanced in order to hit the ground running on this. So they do. By and large, they are risk takers, I would say, and pretty aggressive on because they're there to push the envelope on PPA, and they're focused on it from day one from our perspective.
Yeah. How about you, Mathew? What's your perspective on that? Are these teams risk takers, or wanting to make sure they don't screw up and being a little slower?
I think such teams, they have to be risk takers, as Cam rightly mentioned. We have to really push PPA, and that is a demand of creating a bespoke silicon. And such teams, they also have to be very agile. So as I mentioned earlier, a lot of application for bespoke silicon is very niche. So if there is any change in the market, if there is any change in the software requirement, you often have to go back, update your specs, and make quick changes to the hardware that you're creating. Because if not, you are catering to a very niche market that does not match your product anymore. So you have to be very agile with such teams, make quick changes, really take risks to push the PPA through. So yeah, I would say first-time teams, it is the way that Cam mentioned. Yeah.
I would just say, like, a lot of the bespoke silicon work is being started by companies who may or may not have done silicon before. And so the executives many times are ambitious that they could do things in a certain way. But what happens is when the rubber meets the road, when they actually start the development process, they actually start to hire people who are experts in the field. And that's when they get the hardware engineers and silicon designers, back-end engineers and all. And so obviously there has to be a compromise done at that point in time because the executives have an ambition to do something fast and quick and be more agile on that. But then the traditionalists who are coming in from the industry, they know how to do this hardware and do it well and do it with high yield. So all of those things have to be mixed up, matched up, and the frequency to be matched enough to be able to deliver at the end of the day. But we see this relationship between the desire for an organization to do things and turn to silicon around quickly, but then hardware teams knowing based on their past experiences how to do this well is always a dialogue, and it settles into something unique for every company.
So that need to build a team and bring in talent that's done it before. Yes. Cam talked about headcount limited, and generally would say there's a global war for talent. And so has that affected, or has it been driven by the bespoke silicon trend, or chicken or egg? So, Mathew, you're smiling, so we'll let you go first.
You had two questions of whether, let's say, bespoke silicon is creating more opportunities or is it creating a scarcity in the market? Yeah. I would say yes. Yeah. It's bespoke silicon. It does require a lot of engineers with very specific skill set. So it's very different to create custom silicon for a mobile phone versus a laptop versus a AI accelerator. So even within hardware engineers, you have to have a very specific skill set that you're looking for, and that's not easy to find. So we are creating a scarcity for the right skill set there. And this also brings in more folks into the market and when we are creating more bespoke silicon, there are more opportunities that we are opening up. And I do think that we have many resources that are moving in to the hardware domain because of this. Yep.
One comment I do want to make is that the ecosystem is starting to make it slightly easier for companies to make a decision in favor of doing a bespoke silicon, lowering the bar, if you will. I mean, if you look at EDA, for example, it has evolved over the last 2 decades. And now, if you have to do a silicon, and if you have a reasonably predictable, not, let's say, super aggressive PPA, largely the flows are automated enough for you to start doing some push-button things, right? So if you have to do prototyping work, any company that wants to do a certain application, it's much easier to do that now versus what it was 10 years ago. So that also, and same thing with the infrastructure as well, with the cloud advent and what you can do in the infrastructure for a startup. It used to be at a minimum $10 million you got to raise before you can even see any sample silicon. And now all those bars are lowered significantly from infrastructure, from EDA tooling, from the VC investment circle. All of that ecosystem becomes a lot more friendlier with so many successes that are out there of folks who have, within 6 months, be able to produce some sample silicon, working prototypes, etc. So ecosystem is supporting this as well, and it's continuing to lower the bar for entry.
Yeah, that's a good point. I mean, on the past few years, emulation cells has just been incredible. Before it was certain customers, would fit a profile that would use a little bit of emulation. Now there's tons of emulation, which lets them get to the functionality they need, even run software on that hardware before they even start committing to implementation. So that's a huge growth vector now.
Good. So historically, we've seen the semiconductor industry has been cyclical, and in some ways, we've seen the industry disaggregate or reaggregate in different ways. And so, given where we are with bespoke silicon today, what do you think the future will look like? Will everyone be doing bespoke silicon, or will we swing back to a smaller number of dedicated semiconductor companies that provide common silicon, or something in between? And there is a right answer here, so you'll be graded.
Well, let me give it a shot, see if this is the right answer.
Right.
I think that the bespoke silicon trend is going to keep going, but it's going to shift focus of where it's being done. Like I said before, I think that AI chips, there's going to be maybe a leveling out where, why make your own AI chip if you can get a really good one from this company and put it on your chiplet? And so, and you got this ton of low-level software support that comes with it and does all the things that you want, right? Yep. So I think that that's one area where it will clear out. Maybe in networking as well. There may be some bare bones networking type of designs that, and we see this happening in different ways. Where I think it'll move, though, is further to the edge as we get more and more compute going to the edge. That the bespoke silicon will trend and maybe even doing really advanced stuff on your Alexa could be much more powerful than ever before.
Good.
I think at the end of the day, what's going to determine whether you're going to be successful doing a bespoke or not is, like Mathew was saying, on the return on investment. If you have challenges, there are bars to cross before you can actually invest in a project like that. And what's the return that you're expecting of that, right? Eventually, I think everybody doing their own bespoke is going to settle down in some sub-segments. I think it's not going to be general purpose all the time, even though mass market can still be served with that, but there are going to be application segments that will be better served with something more specific, application specific. And so, but everybody doing their own, it may not also be the right answer, because at the end of the day, there is only a certain appetite in the market. Mm-hmm. So there is going to be some middle ground where it would make sense to still do bespoke for certain applications. It might even evolve into some players who are getting that expertise, those services companies who are experts in doing those bespokes, and they may become those center of excellence, if you will, to do this. But it is not going to be one way or the other. It might be somewhere in the middle.
I completely agree with Cam's and Prashant's take on this, and I want to add, because we've had several success stories with bespoke silicon, I'm sure there are more and more companies that are thinking whether bespoke silicon makes sense for them. So I would expect many of them to, take up the challenge, look at the success stories around them, and start doing bespoke. So I would see an increasing trend, at least for bespoke, but you'll not have 100% adoption. In many cases, general purpose compute does make sense. Yep.
Good. Okay, before we open up to questions, one final question, and I'm going to ask you just to pick one thing in particular that would be surprising or that will become a significant part of semiconductor in the next 5 years. Could be something small, could be something large.
Something that would be surprising that's coming in,
yeah.
An unexpected development.
Like a wild card. This was not in the list of prepared questions.
It was not.
Well, I mean, I can maybe just, I think this domestic manufacturing in semiconductor, I think is going to be a pretty big deal. It's heavily biased towards Taiwan and Korea right now, but then U.S. government is laying a huge amount of emphasis on bringing that manufacturing on U.S. soil. CHIPS Act is about to be passed, and that $52 billion is going to be passed on to building a lot more manufacturing facilities within U.S. So that's a big, huge trend that we will see shifting in favor of U.S. and having more control on our own silicon supply chain. So I think that's one big trend that we will all see over the next, decade or so. I think the other one that I also see is industry starting to really look at secure silicon. I was sort of mentioning this earlier as well, but with all kinds of attacks that have been happening at the silicon level, it's not just software, but even hardware is vulnerable. And how do you develop silicon in a secure fashion, including the secure IP, security verification tool, and doing it in a manner that is secured as well. So I think that's going to become a priority for the industry going forward as well. It's not just the government applications anymore. All commercial applications are vulnerable as well. So that's the other trend I see coming.
Okay. May not be super surprising, but I would expect the performance per watt to get more and more important over the years. It's not something new. Performance per watt has been important for many years, but it's been important because of, let's say, a thermal problem or being competitive against, the other products in the market. But I expect a new or a different factor to start pushing this in the future, which is sustainability. Mm-hmm. I would expect a lot of companies to start investing heavily on, performance per watt, just to keep things sustainable and keep improving that on that year on year.
Yeah, if I were to push it out, 15 years or so, I think non-silicon, non-semiconductor type of compute systems would be emerging for specific. Quantum is a very interesting area. Mm-hmm. Just in the efficiency of compute for certain problems. But probably in 5 years, I was thinking along the same line with Prashant, which is the security angle of what goes into silicon or architecture for security is becoming more and more important on a personal level, not just on for system level. Because we're getting so connected in so many ways that it's it's a little bit mind-boggling right now. So,
well, my prediction to open up the Q&A is that 5 years from now, this panel session will be Cerebrus and DSO.ai will all be replaced by AI bots designing chips. So, okay, well, we have about 3 minutes left. We'll open up for any questions for the panelists. There is a free giveaway for best question.
I have a question. Tom? So, looking over the next few years, what do you think is the most sort of out of left field company that would start doing bespoke for silicon?
Kaiser Permanente.
Healthcare, yeah.
Okay, we talked about chiplets and that being an integral part of bespoke silicon, so that brings into play 3D IC. So I assume people who are doing bespoke silicon are also designing in 3D IC. What are the challenges there? What new physics are you seeing that need to be accounted for, and how are the EDA tool chain accommodating that new kind of design?
Yeah, well, we've got a product integrity 3D IC, and we're starting to work where we've been working with a lot of customers for years on 3D and 2.5D implementation, because we have both packaging and digital implementation at Cadence. What's really accelerating here is the efficiency that needs to be done, because every 3D IC in the past has been a one-off, a little bit of a science experiment, maybe for mil-aero applications. Now to go wider, to be more prolific, to have faster cycle time to get it done, and also to have a wider and more reliable distribution. Lots of analysis, such as mechanical stress, thermal stress, because calculating the thermals for a 1D type of chip was pretty difficult, but it was we had a lot of history on it. Now with two active chips creating their own power profiles, stacked on top of one another even more, it's creating a new type of problem. So getting that fed back so that you can have you can sign off, because it'll explode the corners, especially for sign off between the two chips when you're doing this. So that has to be brought under control. So there's lots of methodologies. They're all solvable problems, but it's just opened up many layers that have to be pushed through to get this done. And so it's improving in efficiency all the time, but there's still a ways to go to make this to make every 2D designer a 3D designer, I'd say.
if there's still time. Another thing, beyond the security would be reliability. I mean, I was in an earlier panel where a lot of the hyperscale companies are like, look, all these machines need to work all the time, and the regular vendors are not necessarily focused on that because their traditional customers don't care. So do you see reliability being a new thing that Bespoke Silicon will be addressing?
Absolutely. I mean, I think, it goes without saying. I mean, the amount of redundancy that we have to put in the data centers because of the reliability issue is just mind-blowing. And like I was saying earlier, as all of these platforms start to go into mainstream, which is pretty much already the case, every industry vertical that we know of has a huge motivation to try and move a majority of their compute into the cloud, which means the demand is going to continue to grow. If that happens, and if we are not solving the reliability problem, that's going to continue to keep the costs high. So for us to optimize the cost over time, it's important, extremely important. Disaster recovery is aside, just reliability in a single zone is already adding to the cost significantly. So we absolutely have to solve that problem.
We're in overtime and this red light flashing, so one last question from the audience. Thank you.
Thank you, John. So I was curious with the panelists, if you had an answer to this, is how does the cost of designing and fabricating bespoke silicon compare to a general purpose design?
I think engineering costs would be a big part of it, and there is the actual cost that gets split by volume. So there is a lot of fixed cost involved. There is a lot of custom things that you have to do, like advanced technologies that you have to bring in. So cost can be on the high side, but at the end you'll have to balance your cost with the amount of volumes that you're making. So it's a fixed cost that gets divided, right? And I think that is more volumes in general and more getting split there. That does not happen for bespoke often. So the cost per device would be on the higher side. Yep.
Right. Yeah, it's, I spoke a little bit about the economics before, the traditional economics where, the chip designer would make a chip at a certain margin, sell it to somebody who made a system, sold it at a certain margin, move up the stream, so forth. And what's really changing this is the difference in economics, where the people that are doing the bespoke silicon, or most of it, are how do I get the software application out to 1 billion people, right? Or multiple software enhance their lives with this application that I have. So that completely, the cost is high for making a chip. It gets more expensive on each advanced node, but it's minimal as far as the opportunity that they see for delivering that application.
Well, thank you, everyone. We said today that we would have an esteemed panel to share insights, challenges, and predictions for bespoke silicon, and I feel like we accomplished the job today. So thank you.